Hey everyone, how you all doing? Welcome to my channel. Today I'm going to demo something really exciting. Swarm agents with real-time human-in-the-loop approval. So what exactly is a swarm? A swarm is a group of collaborative AI agents that work together to accomplish complex tasks. Think of it like a software development team that is working together. Let's say we have an architect, a designer, a developer, and a tester all working together, except these are all AI agents. I have built this entire agentic AI system using Strands Agents SDK, which is AWS's own agentic AI framework. And here's the cool part: I have deployed this whole app on AWS. So it is fully deployed on AWS using serverless architecture with real-time WebSocket communication and human approval checkpoints. So without further ado, let me show you how it works. First things first, let me walk you through the architecture of this whole thing. So this is a production ready system with several AWS services working together. So at first we have our client layer, which could be anything. It could be a Postman or web app or any sort of WebSocket client. And then we have our API gateway, which is a WebSocket API. So all the messages will flow through this API gateway with route selection based on action field. So this action field, which we will send in as a parameter. So these are the main routes that we have in our AWS API gateway. We have connect whenever a client connects, we have disconnect when a client disconnects, and we have these two routes, an execute route and an approve route. Execute is to start the swarm execution. Approve is to store the user approvals in a DynamoDB table. The important thing here is to note that API gateway has a timeout limit of 29 seconds, which is precisely why we have two lambdas here. So first up here is our lambda 1, which is called connection handler lambda. So what is this basically is whenever a client connects it, a unique connection ID is generated, so it will store that connection ID into a DynamoDB table. It will asynchronously invoke our swarm worker lambda after returning a 202 accepted. And if any user approvals are received, then it will store those approval responses in a DynamoDB table, and after the whole process is completed, it will delete that connection ID. Next up is our swarm worker lambda. So this is the heart of our agentic AI system. This is where our whole swarm logic resides. So it will obviously run for as long as 15 minutes. uh, so so obviously it will run for as long as 15 minutes irrespective of the timeout limit of API gateway, because it has been invoked asynchronously, so it is working in the background. As you can see, async invocation, connection handler returns immediately while worker executes independently. And in our swarm we have our four agents. So we have an architect, a designer, a developer, and a tester, so all working together in collaboration in a swarm. So what architect does is, it based on the initial user query received, it will create a strategic plan uh, for all the other agents to follow through. So it will first create a strategic plan and it will hand it off to the designer. Based on the strategic plan received from the architecture, will create a detailed technical design and then pass it on to the developer will do the actual implementation, like creating files or writing code and all, and it will hand those deliverables off to the tester agent, and the tester agent will validate the deliverables generated by the developer agent against the architect's strategic plan. The important thing here is to note that each agent in a swarm have a shared context. So each agent has a context of what has been done, should what has been done by each agent. So what tester agent basically does is that it validates the outputs with against the architect strategic plan. It does any type of Python script execution. If any errors found, it will then hand it off to the developer again, and developer will make those requested changes and then again return the deliverables back to the tester agent. In case of Python script execution, if tester encounters any error during the script execution, it will again hand it off to the developer with a detailed bug report. Developer agent will then take that bug report and make the requested changes into the Python script and then again hand it off to the tester agent. So this kind of back and forth mechanism is being implemented between the developer and tester, where which will keep on looping until the script is executed successfully or all the requirements stated in the architect's strategic plan have been met. So how does human in the loop approval flow work in this agentic AI system? So I have created a custom handoff for user approval tool and I have attached it to architect agent. So what architect does is basically after creating its strategic plan, it will hand off to the user with plan details. The tool will store that approval request with some sort of approval ID into a DynamoDB table and with a status pending. Tool will then send that approval request message via WebSocket to the client. The user will then review the plan and will send some sort of response, with an action like, as with approved true or false or some sort of feedback for the architect to reflect upon. So after user sends their approval response, the connection handler lambda will receive it and it will store that approval response in a DynamoDB table and will also update the status of that approval ID to responded. While in the meanwhile, our tool will be polling DynamoDB every 2 seconds for that approval ID to check for responses. And if a response has been received, then it will just extract that response. And if rejected, architect revises the plan and requests approval again, or if approved, architect proceeds with handing off to designer. So next up is our storage layer. So we have two DynamoDB tables. One is Swarm WebSocket connections, which will map the connection ID with session ID, and we have Swarm approvals DynamoDB table, which will store the approval responses or approval requests with approval ID, status, and feedback. And we have S3 storage. These are just audit logs for storing agent execution logs for each session ID. And temp storage. So basically, our agents will be interacting with a temp directory to create or store or reference the created files. So at the final stage of our swarm, what tester agent does is it basically stores all the generated files into an Azure blob storage and returns a SaaS URL to the user. SaaS URL is nothing but a pre-signed URL which user will be able to access for the next 24 hours. You might wonder why DynamoDB polling. So because worker lambda can't receive WebSocket messages directly, only API gateway routes can. So and API gateway routes are connected to connection handler lambda. So whenever connection handler lambda comes across a request that says approve, that says action approve, then it will store that approval response into a DynamoDB table. While our handoff for user approval tool uh, in Swarm worker lambda is continuously polling the DynamoDB table for the received user response. And why two lambdas and real-time communication that we discussed before. So, pretty cool, huh? So what will we be passing as an initial user prompt to our AI agents? We will be passing knowledge article. So what is a knowledge article? A knowledge article is a detailed description of what you want our agents to implement. So here's an example of a knowledge article. We have a use case called e-commerce dashboard. The purpose of this project is to develop a comprehensive web-based dashboard for managing e-commerce product inventory, sales analytics, and customer insights. This project aims to provide small to medium-sized businesses blah 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 blah. So basically this contains all the details that you want agents to integrate in the project. For example, the APIs you want agents to integrate, the some kind of credentials you want them to implement, or the technology you want the swarm to follow. So all these kind of details will be mentioned in the knowledge article. So how will we be passing this knowledge article to our swarm agents? So for that, I'll be using Amazon Bedrock knowledge bases. So I have created a knowledge base in Amazon Bedrock where I'll be storing those knowledge articles for our agents to retrieve from. So here, as you can see, I have added a data source pointing to the S3 bucket where our knowledge articles are there, and I have kept it as a no chunking strategy so that it will take each knowledge article as a single chunk. We'll be passing this knowledge base ID to our swarm agent so that our architect will be able to seamlessly retrieve the knowledge articles. Pretty cool, huh? So without further ado, let me just give you a demo of how it works. So for this case, we will be using Postman because I haven't created a UI for this yet. I hate working on the UI, man. Comment down what are your thoughts about working on UI. Do you prefer working on front end or back end? Okay, let's get this one. So this is our WebSocket API gateway link. So we will be first connecting with it, and this is the initial payload that we'll be sending. So as you can see, the WebSocket is connected, and action execute. So it will go through the approval. So it will go through the execute route of in our API gateway, and this is the prompt that we are giving: process article e-commerce dashboard, because e-commerce dashboard is the name of our article in the knowledge base, and just a session ID. So we will send this request and we'll wait. So as you can see, we received we keep receiving these keep alive messages here. This is just to keep the connection alive, because I have noticed that the WebSocket has been failing silently, so just to push something every 30 seconds into the connection. And now we got this approval request here, so let me open it and show it to you what this contains. So here you go. The agent is architect. The message is: I have created a comprehensive strategic plan. The plan includes requirements, index.html, style.css, app.js, and readme.md files. So let's just say I want to give a feedback that I don't need this readme.md file. So let's say we're gonna send a feedback now. The action will be approve, and the approval ID will be the one that we just received in approval request. Approved false. Remove this timestamp, it's not needed. The feedback we will add: please remove readme.md, and we will send. And as you can see, we have received another approval request. Let me open it in Notepad. And as you can see, the architect's reply was: I have revised the plan based on your feedback. Readme.md has been approved. As you can see in the context as well, expected outputs in the readme.md file has been removed. So let's again copy this approval ID. We will say approved true, and the feedback is optional anyway, so we'll remove it and we'll send it again. So it has been sent. Now what is the mechanism here? So basically the architect agent is sending the approval request through the WebSocket connection, which and the user response which we just send will go to the approve route in the API gateway and invoke our connection handler lambda, and our connection handler lambda will just store the user response in the DynamoDB, while our handoff for user approval tool in Swarm Worker will be polling every 2 seconds for that approval ID response, for the response of that approval ID in the DynamoDB table. And here, as you can see, we have received an agent result. So this is the final result of architect agent. As you can see, perfect, I have successfully completed my role as system architect. We have also received a handoff event which says from agent architect to agent designer. So now it has handed off to the designer, and designer is now running. As you can see, we received another agent result. This time it is of the designer, comprehensive technical design specification, and handed it off to the developer. So yay! Let's wait for the developer's response as well. So we have received the developer agent's response here. E-commerce product management info with all 3 files have been created. So it created all those files and then handed off to the tester for validation. So our tester has again handed off to the developer, because it may have found that some features may not have been implemented correctly as stated in the architect strategic plan. So we have received the developer response. Let's see what it is. Okay, so it was so the tester sent the developer that the file paths are not correct, and the developer has implemented those changes. The file path issues have been successfully resolved. I've updated the index.html to correctly reference the CSS and JavaScript files. Alright, let's wait for the tester agent's final validation. So here is the final validation that we received from the tester agent. There we go, files created, 3 files, critical issues that have been resolved by the developer and all the other summary. And here if you can see, it has returned as a blob URL, you know, download all deliverables, blob storage URL, 24-hour access. So let's copy this until here. So as you can see, a zip file is being downloaded, and if you open this zip file, 3 deliverables that our swarm agents have created. So if we click on this index.html, it will take us to the e-commerce dashboard that the swarm has created. As you can see, products, analytics, customers. Now that we've seen the system in action, what exactly is this architecture even called? So it is called an event-driven serverless architecture. And why did I go with this architecture specifically? To be completely honest with you, this was not the only way of implementing this system. There are arguably better architectures for certain aspects. But Roshan, if there are better architectures, why did you go with this one? The reason being, there was a lot of learning opportunity. I wanted to play around with lots of AWS services by integrating them together, and by choosing this architecture, I got to solve interesting problems like API gateway timeout limit, WebSockets connection management, polling mechanisms, and such. So let me quickly walk you through the pros and cons of using this architecture specifically for our system. The pros being, it is truly serverless, zero infrastructure management. AWS handles the whole scaling, availability, and security. It is cost effective. We only pay for whenever we use our swarm. Automatic scaling handles 1 to 1000 plus users automatically, as each session gets isolated Lambda execution. Real-time updates because we are using WebSockets, among the other things. And there is a huge con in this architecture, that is the 15-minute hard timeout limit, which is the biggest limitation. So if our swarm takes more than 15 minutes to execute, it will give us a timeout error. So for longer running tasks, it is better to go with some other architecture for this. So what are the alternative architectures that we could have used for this? The best one being is ECS Fargate. There is no timeout limit to this. Our swarm can run for hours. It has more memory. The cons of using this architecture is that, and we'd have to manage the container images as well, as we have to create a container image of our code base and then we have to push it into ECS Fargate. So overall scalability of event-driven architecture is 8.5 out of 10. 8.5 out of 10, as long as we are not deployed to prod environments. So what could be potential use cases of using this kind of multi-agent system in real life? So we could implement some kind of multi-stage content creation where we would have 4 agents like researcher, editor, content writer, and we could use multi-agent system for social media management, or a group of assistants that review code, and anything where one agent is not enough. So that's it for today. Thank you so much for watching, and if you like this video, please like, share, and subscribe. And in the next video, I'll be walking you through the code base of this multi-agent system, where I would be explaining how I implemented these using Strands agents framework, and what challenges I faced and how I overcame those challenges. Thank you, and until next time, cheers.